Michael, on that note, let's jump into the OpenConv tutorial. From HashgraphDAO, as you mentioned at the start, and you're going to demo today the OpenConv plugin that will basically talk you through how to use Eliza OS for agent-to-agent communication. So maybe there's a little bit of a link up between yourself and Leon here, who knows, but let's bring up your slides and yeah, feel free to kick it off.
Yeah, absolutely. Just for context, I did an intro early on, but I'm Michael Cantor, president of Hashgraph Online DAO, and Hedera. A lot of the entities might be confusing at times. And last month, I think 2 months ago, we created this new standard for AI to AI communication called OpenConvAI. You can say it a few ways: OpenConv, OpenConvAI. The way we imagine is convey, like you're conveying something, but you could also pronounce it the other way.
That was my English coming through.
No, you're good. A lot of people say OpenConv. It's like you have this theory about like product messaging and how people will convey things, and then it doesn't always pan out, which is an interesting learning experience for us. But
just before you jump in, just a quick reminder to anyone listening, both on Discord and on the X stream, if you have any questions, if you're listening to Michael's tutorial and you want to jump into something, feel free to drop it in either the chat or into the Discord chat, and we'll make sure that we either ask it as it comes up or we'll circle around at the end. And yeah, Michael, feel free to take it away. I'm looking forward to this.
Absolutely. Yeah. So Hashgraph Online DAO it's a decentralized entity. We are a consortium of 10 leading organizations on Hedera. And our main goal is creating a fully on-chain agentic internet that under the hood is utilizing Hedera, the consensus service, and other networks as well to develop open source standards, tools, and services. So in Hashgraph Online DAO, we have, as I said, 10 members. For example, we've got like Hashpack, is a leading wallet on Hedera at over $1 billion of assets, I think, cumulatively. Bonzo Finance, leading DeFi protocol for lending and borrowing assets. Builder Labs, which is behind companies such as Headstarter and NameJob. We've got Hgraph, the leading Marinode provider. Neuron, a great innovator in the space, which is doing fantastic things in DePIN and aviation, over millions of dollars in contracts on that, which is insanely interesting when you think about it. We've got Launchbadge, KiloScribe, Syntax is the leading company behind the leading NFT marketplace on Hedera. And Turtleman has helped accelerate Hedera for years with NFT tooling and Hedera tools in general. So at Hashgraph Online, again, we come together and we build open source standards. And as of today, we've developed a lot of really tangible traction at Hashgraph Online. We have over 280 testnet agents running right now. We just had a hackathon with over $30,000 in prizes that had 300 registrations, 84 submissions. And we did a Hedera X AI stream the last 2 days, which actually hit combined over 500,000 views. We had special guests such as Lehman and Mance, a number of showcases and great pitches from our hackathon participants at Hedera X AI. We've done over 28 million transactions on network. And we do over 1,200 weekly NPM downloads from our various SDKs, primarily the standards SDK and standards agent kit for interacting with OpenConvAI. And we also do around 300,000 daily CDN requests to our Inscription CDN, which handles loading decentralized files to the Hedera consensus service. Suffice to say, Hashgraph Online has done a number in terms of volume and traction, and things are progressing. And it all comes down to these open source standards that we've built that honestly, they just live in markdown files, and it's not sexy at all. But when you think about it, the entire internet is actually built on standards like this: HTTP, UDP, and now this new thing that Coinbase is pioneering, 4L2, right? It all just starts in a markdown document. On our side, with OpenConvAI as an agent-to-agent communication platform, agent-to-agent communication protocol and standard, you can actually access OpenConvAI through any front end that implements the standard. Our preferred front end is Minscape. So if you want to check out OpenConvAI, go to minscape.tech, and you can connect with a testnet account and start chatting to agents immediately. So you can see on the screen, there's already an example of this where you can find all the agents on the decentralized registry. That's all recorded on the Hedera consensus service as actual transactions. You pay to register. You have these conversations between all of your agents, and each conversation is on their own topic ID. And you can see, like, in this interface, I'm talking to the standards expert, which is running on its own RAG database, implementing the protocol, and it's responding back to me. How do I inscribe a file? Standards expert pulls from its RAG database and boom, pushes its content onto that communication topic, and I can keep responding, and I have this message queue. So how does this tie into the wider scheme of things, and why do we need a decentralized AI to AI communication protocol? The way that we're seeing the world, and I don't know if everyone watching the stream is aligned with that, is I think we're all going to be chatting to AI agents in the future. We can see it already. The writing is on the wall. It's there. You can just think about how often are you going to Google versus going to ChatGPT to ask a question. You can see that everyone's habits is starting to shift quite quickly away from going to websites that they would normally go if they're looking up to find a new credit card or some kind of SaaS product or whatever, and going to AI agents instead. That is the future. And if that is the future, there's going to be millions and millions of these agents, and it's only going to go up exponentially. And we're going to have to contact them, and we're going to have to talk to them, find them. How do we do that? How do we discover them properly? And how do we do it in a way that's not centralized? How do we have these reputation systems around these agents so that we know that we're talking to valid actors? And most importantly, from the Web3 perspective, how do we enable this on-chain, decentralized, implicit commerce that is easy to use, not worse than previous systems, where you can just get, as somebody who's maybe tokenizing your agent and you have a unique offering, how do you make it monetizable in an easy way? I think all of these reasons are huge opportunities to have a decentralized AI to AI communication standard that just works. We've built OpenConvAI on Hedera, which has a lot of benefits. From the Hedera perspective, we have single-step implicit monetization, and we'll talk about that a little bit more. You have cheap, fixed transaction fees. It costs 1/100th penny to submit a message on the Hedera consensus service, meaning it's not a huge leap when you think about the credit compute costs for actually running an agent and running in a large language model, or if you're using OpenAI and Claude, it's just like the pennies you put in the slot machine. So yes, you have to pay to talk to these agents in a decentralized way, but it's such a small amount compared to what you're going to be paying already for your credits. It's actually worth having a recording of these conversations, because now we have this idea of verifiable finance, right? We can go back into all of our conversations, and more importantly, we can have these orchestrations. Like, I could be talking to an AI agent that's a generalist, and it's able to talk to 6 or 7 other agents to process my query, all in a decentralized way. We kind of replay things and see exactly what happened. When that comes to payments and crypto, it couldn't be more important than ever to have that verifiable. So how does OpenConvAI work? I'm not going to jump into all of the technical details, bore the crap out of you, but in a nutshell, let's say you've got Agent A, which is running on the Eliza OS framework. It's using the Eliza Hedera plugin and the Hedera agent kit. On the right side, you might have another agent that maybe is implementing Eliza as well, where maybe it's just like a generic HCS10 setup. Agent B talks to Agent A and says, I want to transfer 50 HBAR to some account. Agent A utilizes the Hedera agent kit and Eliza's plugin, and it finds the action to create a Hedera transaction. It sends back the transaction bytes for a scheduled transaction. Scheduled transactions are these cool things, and we'll jump into this demo video here in a second and come back to the wider presentation. But they're really cool because what they mean is if you're talking to an agent and you have a transaction that might expire in 120 seconds, that might not be great. I think oftentimes in our experience as users, we will open up a tab and ask something for ChatGPT and forget about it. If we forget about it and the transaction expires, well, that sucks because now we have to pay for another prompt. Scheduled transactions, you don't have to worry about that because you can schedule them to expire a month up to 3 months from now. So you don't have that same risk. So the user goes and they go and accept that transaction, and boom, it's sent down through the communication topic that they're both on. Agent A and Agent B, they both have these things called inbound topics. Your inbound topic is basically like your inbox. So if Agent B wants to talk to Agent A, they send a request to Agent A's inbound topic, which is on the Hedera consensus service. So you can physically go on HashScan and you can see this topic. And they send a connection request. And they say, Agent A, I want to talk. Agent A looks at that connection request and they say, okay, cool. I see that you want to utilize my services or something like that. So Agent A accepts the connection request on its inbound topic, and then it records on its inbound topic that it has approved that connection. Once it's approved that connection, it creates a new shared connection topic. And now Agent A and Agent B are able to talk to each other and do commerce. Next, I'm going to actually switch my screen here. And I'm going to show you guys a little bit of a demo. We showcased this at HederaX AI initially, which shows the human in the loop for what an interaction would look like from a human talking to an AI agent utilizing this Eliza OS integration.
Nice. And this is all built with Eliza OS on the back end, right?
Yeah. So with OpenConvAI, we've built out a Eliza plugin, Hedera, which I'll demonstrate here. I won't bore you guys with all the details, but we do have this GitHub pulled up, which would be the new Eliza Hedera plugin. And from the kind of like more nerdy details, I don't know how technical the audience is, so I'll run through this quickly. And then I also have a little terminal pulled up where I could show you this running live.
It'd be cool for you to demo how someone would use this, and yeah, consider it for a technical audience.
Yeah, sounds good. So with the Eliza Hedera plugin, there's kind of two key components to it. So there's a service which you pop open to, let me just make sure that I'm using the right terminology here between the different versions of Eliza. It is the, I think it's in the plug, no, not the plugin section. Sorry.
That's okay. It's all good.
It's
V2.
No, I think it's still V1. When you set up your plugin, you'd install the Hedera agent, and then you would put it into, sorry, spacing right now. Yeah, in your default character, you would just pop in the Hedera plugin, and inside the plugin itself, you would pull in this OpenConvAI client, and then you'd pop that client into, forget where you pull the client into right now. It's the top of my head. There we go. Yeah, it is called a client. I wasn't sure if the terminology was something else. Yeah. So you have your OpenConvAI client over here, which is similar to the Discord client or the X client. Yeah. The way that we're looking at OpenConvAI is like it's another medium to communicate on for your Eliza agent. And inside that,
just on that point, yeah. So the client is where you interact with the agent through. So if the client interface is Twitter, it's an agent that speaks to you on Twitter. If it's on Discord, so this would be in the OpenConvAI. So the users would interact with this plugin via your platform.
OpenConvAI. When the plugin starts, automatically it's utilizing the Hashgraph Online Standards SDK, which does most of the heavy lifting. And as soon as you have this client running, automatically you can set up to monitor all of the incoming connections. So as we were talking about before, there are these inbound topics and there are these communication topics, right? So inside of the client, there's this watch connection request function that's run automatically when the client is booted up. And basically what it's doing is it's waiting for new incoming messages to, let me blow this up a little bit because I'm noticing to see. It's waiting for new incoming messages to inbound topic ID. Inbound topic ID is a topic that's stored on the Hedera consensus service where you can write messages to, and that's it. You can think about it as like a REST API almost, and you're able to scan for these messages as they come in. And when the agent realizes that, okay, I've got a new connection request, then it'll check if that connection request has already been approved. And if it hasn't been approved, then it goes and it just automatically accepts that connection request. In the future, we'll add conditions into this plugin where you can maybe deny certain requests because you're not interested and because they don't meet certain criteria for your agent. And as you're doing this, once you've accepted those connection requests, now you have a bunch of communication topics. So the communication topics are private. And the way they work is your agent has a public key, my agent has a public key. We take their public keys and we create a threshold key, which means that only the two of our agents can chat on that communication topic. So the agent is scanning for these communication topics, which are now private, and it's looking for new messages. The minute that it finds a new message, it calls this handle message function. And in the handle message function, it'll read the content, see if there's any files and things like that. And eventually it'll go and respond to that message if it makes sense to respond to it through this generate response function. This generate response function under the hood will, because it just works through Eliza, eventually, if you've got the plugin set up properly, it'll call the create transaction action that we partially had demoed there on that video, and that's using the Hedera agent kit. It's really simple. It's just one single action, and it's able to take your natural language query and figure out how you want to interact. And there's two modes here. There's the provide bytes mode, where if your agent is running in that provide bytes mode configuration on the plugin itself, then the agent will send back transaction bytes, either as a scheduled transaction or as bytes that you can parse and turn into a transaction. Or if your agent is running in a direct execution mode, then it can decide if it wants to actually go and execute it on its own account. The difference there is the human in the loop versus the agent acting autonomously, if that makes sense. And what that kind of comes out to, here I've got a tab that's actually demonstrating, again, that Eliza action. You can see hello from Hedera helper, which is part of the character file, and say I want to create a token called yes with 1,000 supply. Now I say I want to go and transfer to HBAR to account 800. We'll see if this works. I'm gonna have to disconnect and reconnect here.
So just whilst you're doing this, is there an element of setting the character for the agent? How, if you want the agent to have a personality, is that just a standard Eliza OS character file that lives alongside this plugin, and then there's no modification there for them needing to, if they're looking to use this, there's no modification needed on that side of things?
Yeah, absolutely. So it is basically like a standard character file that you have in Eliza OS. There's
Mhm.
very little work that you have to do as a developer to actually start using OpenConvAI. It's like similar to Discord or Twitter. You can stylize your agent to have any kind of lore and character that you would with any other agent Eliza. So that means any existing agent can now just plug in OpenConvAI and start using it immediately.
Okay. And this, as you touched on at the start, so this has native on-chain transactions built in, I guess executed on Hedera. Just, I don't know if it's a good point to recap the other functionality that it enables for agents. Not only
Yeah,
to or not even verbally communicate, but communicate through written language. But what else could they do?
yeah, so that is the two big features that the OpenConvAI Eliza integration does, and you can see that I'll pull up the actual terminal here in a minute too. But I thought the physical demo is a little bit cooler. This is actually running Eliza on a terminal in the background, and mainly the plugin works through the Hedera agent kit. It takes your
Mm.
natural language query and it gives you back the transaction that you want to process. Now, the cool part about this, and you'll see it more with the example above where you're creating a token. There are a lot of agents that are kind of like very structured. Say, I want to create a token with 2 decimals, this symbol, that supply, etc. But humans are dumb, okay? Humans make really bad prompts all the time. And what we've built with the Hedera agent kit is that flexibility. We've created this note system essentially, and it's like the thinking process for the agent where it starts making decisions for you. So you say, I want to create a token called yes with 1,000 supply. It starts making these inferences. And it says, I'm assuming you don't want any decimals, so I'm going to set them to 0. I'm assuming your supply type is going to be finite. That's the default. And we'll set a maximum supply. And I'll make the token symbol the same as the token name. And then in the UX of OpenConvAI, you get this transaction prompt and it's giving you all that information. And as a user, the cool thing about this is you can say, okay, those inferences make total sense and I'll just approve the transaction. Or I can write back with another response and be like, no, that's not what I meant. But you have that flexibility of being able to change that. Now, let me show you on the background, see if I can get the terminal running. That's actually running Eliza. Bear with me a second here. And it can show you through that end-to-end process of connecting to a new agent through the Eliza plugin. Let me just get this terminal up. Boom. So this is a Warp terminal that's running Eliza right now through the plugin.
It distorted, just it might catch up for a second. The stream might be the bandwidth on the stream.
Oh, is it lagging a little bit?
This is a bit distorted. Can't quite read the text. Let me make it out. It's quite strange. I've not seen that before.
Oh yeah, it's very blurry. See, I've got 720p up here.
I'm quite sure there.
It might be broadcasting on, because sometimes when you do these things on X, it might be broadcasting in 720p. I don't know. The broadcast is low res too. I'll just go back to the other screen. It's okay. I think.
Yeah, sure.
It's a shame that we can't see it, but.
Do you have any supporting guides or any kind of materials that might be present in?
Yeah, we will have official documentation around the Eliza OS plugin soon, but mostly everything is documented here. If you go to the Hashgraph Online website, we have the standards SDK and we have the standards agent kit. We'll have another section here very soon for the official Eliza plugin, as well as more stuff on the Hedera agent kit. So the best place to always get documentation, things like that, is to go to hashgraphodonline.com, click that standards tab and start digging into the documentation. You can look at our individual standards for how they're implemented, but if you want to build out your implementation, probably the library documentation will be the most interesting to you. We'll have some advice to like how to set up your character in Eliza in a way that kind of makes sense. I think default, if you've already got characters running in different integrations like Solana, you're probably good to go. You just pop in the plugin and then it should work immediately.
Nice. Amazing. This has been great. Thank you for sharing. I think just before we wrap up, is there anything that you'd like the viewers to do? I know this has been hands-on with people over the last week, if I'm right, but I don't know if you want people to come and test it. Is there anything that you're offering for agents to come in and list, for example? Or, yeah, all of the above.
Yeah, absolutely. So today we've had almost 200 agents set up in testnet. What I'd love for our folks to do is come to testnet, set up your agent, see how simple it is, number one, and reach out to us because we'd love to partner and feature agents that are really cool inside of OpenConvAI, especially if they're utilizing Eliza and you've got like an interesting character and lore behind that agent. I think it'd be really cool. So reach out to us. We can help feature you on our socials. We just had our HashgraphDAO AI demo day. There's over 500,000 views on that side. So I think it could be a pretty interesting like partnership opportunity. Go to the Moonscape website, learn about how to implement OpenConvAI as well. We have this Learn portal here, or you can also come to the Hashgraph Online website, which is more like the standard side and library implementation aspect.
Nice. Yeah, we had a question from the Discord audience if they can get a link for Moonscape. I'll drop that into the chat after we finish the stream. But Michael, I don't know if you've got that to hand as well. And yeah, that nicely brings it up to the end of the session. That was great. Great to see these. Great to see the development is still ongoing in many ways, and that there's more utility being introduced to Eliza OS literally weekly at this point. So yeah, amazing. Thank you so much for sharing this. I think what we should do is make sure that there's some links for the developer community that we circulate after this. So if you've got anything, please do share, and then let's call that a wrap.
Yeah, that sounds good. Again, Ken, thanks so much for coming, and huge thanks to the Eliza team for making it to HashgraphDAO yesterday. It was great. And I'm just really excited for Eliza agents to start being able to talk to each other in these decentralized ways.
I agree. Yeah. I think whether it's just a UX layer for crypto, whether it's a bit more sophisticated in terms of how does this agent-to-agent economy emerge, I think later this year, you will have agents operating on your behalf, probably interacting with other agents. I don't think it's that far away. We maybe need some infrastructure improvements on the verification side to make sure that you can trust the other agent, if that makes sense. But again, that's being built. There's multiple T solutions now. There's multiple ways to host, or even decentralized inference is becoming a thing as well. Once you remove those dependencies and you can trust an agent to act on your behalf, I think it's going to move quite quickly from there because the framework's there. I think that the UI and the way to build it is there. I think that there's a few missing pieces. But yeah, thank you so much again, Michael, for joining. It's our pleasure. And to everyone listening, thank you for tuning in. And we'll see you next week.
Absolutely. Thanks, everyone.
Cheers, Michael. Bye-bye.
Cheers.